We're going to talk about how helpful it is to have the double angle formulas, or identities. First thing, when we're given cosine of theta is 5 over 13, is to draw the point out here and then construct a triangle based on that, because we're implying that there's a side here, 12, and this side is 5, and the hypotenuse is 13. And then we're going to say, you can see what the sine would be, and you can see what the tangent would be. Okay, fine. But that's after we draw our angle, that makes it pretty clear without thinking too hard. And then we say, okay, so we're going to find the sine of 2 theta. Okay, well, we use the formula. The formula's down here, by the way. There's the formula. Okay. And we say, okay, well, if I want to do this, I'll go ahead and I'll say the sine of theta and the cosine of theta. And since I have a triangle to look at, I know what the sine and cosine are. And when I do cosine, same thing. I can square the cosine of theta, multiply by 2, and subtract 1. Okay? So, oh, and tangent. Okay, tangent has its thing going on here. So that's what we're going to do. So we say there's some triangle being implied here. Let's see what it is. It looks like the opposite side is 3 and the hypotenuse is 5, so we could use Pythagoras here and to find out that 4 is over here, but we kind of know 3, 4, 5. All right, and then we say, okay, so if this is angle U, what about sine? They ask us to find sine of 2u. Well, sine of 2u is equal to 2 sine of u cosine u, right? Look up here. Yep, that's right. Okay, so we say, what's the sine of u? Well, they kind of told us already. It's 3 over 5. And then the cosine, what's the cosine of u? That's 4 over 5, right? So times 4 over 5. And this is going to give us, I don't see anything that would cancel top and bottom, so 3 times 4 is 12, times 2 is 24 over 25. So that's my answer there, to the sine of 2u. How about the cosine of 2u? Well, let's see, the cosine of 2u, we look up there and we say, what is it? Oh, okay, we'll use this one right here. And so we say, okay, cosine squared u minus sine squared u. Is that right? Sine squared u. Yep, that's right. Okay, so, well, let's see. What's the cosine of u? Well, we set it up above. It's 4 over 5. And it's squared. And we're going to subtract sine of u squared. So let's see, that's 16 over 25 minus 9 over 25 is equal to 7 over 25. And there we go. That's cosine of 2u. Okay, and then lastly we'll do the tangent of 2u. And the tangent of 2u kind of seems like if you factored the 2 out in front, which you're not allowed to do, unless you put this on the bottom. If you put this on the bottom, then it's okay. So you say, oh, that 2, I'll just factor it out front. Well, as long as you have the bottom. Okay, so 1 minus tangent squared u. All right, so let's see what this is. Well, first of all, what's the tangent of u? Well, the tangent of u is opposite over adjacent, 3 over 4. And then on the bottom we have 1 minus the same thing squared. So 3 over 4 squared. So we have the 2 and the 4 will cancel, right? And I will get 3 over 2 on top. And on the bottom, I'll have 1 minus 9 over 16. And I think I'll carry that on down here. We'll say that's 3 over 2 over 7 over 16. I'm going to multiply top and bottom by 16 because I don't want a complex fraction. And the 2 is going to cancel, so that leaves me 8 times 3 is 24 over 7. I think that's it. What else could I do? Okay. So it might be instructive to try this and double the angle. I think, well, it'd be an interesting thing to experiment with this and see if we could make our calculator confirm it. But anyway, we know this to be true from the rules.